Hi everyone, welcome to another video of computer architecture and microcontrollers. So we are going to next see about arithmetic instructions, but before going into that, we will see one of the important registers in 8051, which is the program status word. So we will see what is program status word. We will see what are its contents, what is the importance of this program status word, and how it affects various programs. Let's go into the video. See, program status word is part of the RAM. So you know that RAM is divided into various parts. Initially we have the bank of registers, then we have bit addressable area, scratch pad area, and after that from memory locations 80 to FF, it is for the special function registers. You can see that in the special function registers, this address D0, so D0 represents 8 bits, D7, D6, D5, D4, D3, D2, D1, D0. It represents the program status word. So program status word is one of the registers, one of the special function registers which is present in the RAM address location D0. So since it's an hexadecimal number, I am writing 0D0. Now, what is this program status word? As we saw now, it has 8 bits. This is D7, D6, D5, D4, D3, D2, D1 and D0. Now, each bit has an importance. D7, or it is called PSW.7. PSW.7, it is the carry flag. We are going to see what is carry flag soon, and short form is CY. Then PSW.6, that is the 6th bit, that is the 7th bit. If you are starting from 0, it is the 6th bit. It is called the auxiliary carry flag. Auxiliary carry flag. Short form is AC. Then PSW.5, now you can see PSW.4 and PSW.3. They are together known RS1 and RS0. It is used for selecting the register bank. So you can see register bank selector bit 1 and register bank selector bit 0. So 2 bits can be used to select one of the 4 banks. We have already learned now there are 4 banks are there. 4 banks of registers are there. Bank 0, bank 1, bank 2, bank 3. So to select one of the banks, we are going to use this combination RS0 and RS1. So if RS0 equal to 0, RS1 equal to 0, then register bank 0 will be selected. If RS1 equal to 0 and RS0 is equal to 1, register bank 1 will be selected. And if RS1 is equal to 1 and RS0 equal to 0, register bank 2 will be selected. And finally, if it is 1, 1, you can see 3 will be selected. So these are the 4 choices by which we can select one of the 4 register banks. We will see this in the next slide also. Then we have PSW.2, which is used for the overflow flag. Okay, and then we have PSW.0, which is the parity flag. So understand that which is represented by P. So we can find that there are 4 flags are there. What are the 4 flags? It is the carry flag, auxiliary carry flag, then we have the overflow flag and the parity flag. 4 flags are there. And then what you can see is 2 bits we are not using at all. This bit PSW.5 and PSW.1, they are left unused. So you have to understand the importance of these 8 bits. Out of these 8 bits, 2 are unused, 4 are used for flags, and 2 are used for selecting the registers. Now we will see the importance of each of the flags. So I already told you there are 4 conditional flags. The first one is the carry flag. So this flag is set whenever there is a carry out from the D7 bit. See, we will two numbers add. Suppose it is 23H plus 47. So 23 means actually what? We are actually doing 23 plus 47. Actually 23 means 0, 0, 1, 0. 3 means 0, 0, 1, 1. 4 means 0, 1, 0, 0. And 7 means 0, 1, 1, 1. We are going to add it. 1 plus 1 is 0. Carry 1. 1 plus 1 plus 1 is 1. Carry 1. 1 plus 1 is 0. Carry 1. 1 plus 0 plus 0 is carry 1. 1 carry 0. 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0. And there is no carry. So when you are adding two 8-bit numbers, your answer is 8-bit number plus a carry bit. So whenever there is a carry out of the D7 bit, so this is D0, D1, D2, D3, D4, D5, D6, D7. This is the D7 bit. Whenever there is a carry from this bit to the next position, carry flag is set out. And this flag is affected after an 8-bit addition or subtraction. Remember, when is the carry flag set? It is affected after an 8-bit addition or subtraction. And you can also set this carry to be 1 or 0. So how can you do that? You can use the command setb set bit C. That means this C stands for the carry bit CY. So then CY will be equal to 1. Otherwise it is PSW dot 7. That is what we saw last. PSW dot 7. So PSW dot 7 will be equal to 1. And you can clear. This is setting the value. You can also clear CLRC. So that means the carry flag will be cleared. So carry flag value will be equal to 0, or I can say PSW dot 7 is equal to 0. So adinu vendiyulla command aanu setbc and clrc, set bit carry and clear carry. I hope it is clear to you. So carry flag is set when there is a carry from D7th position to the next bit. Carry out from the D7th bit. apparana nammal carry flag set agum. Next we will see the auxiliary carry flag AC. So auxiliary carry flag is set when there is a carry from D3 to D4. nammal bits eduthumbol we have D0, D1, D2, D3, D4, D5, D6, D7. So either 4 bit, this is 4 bits and this is 4 bits. So auxiliary carry flag is set when there is a carry from D3 to D4. That is the time. Auxiliary carry flag is set when there is a carry from D3 to D4. So when you are adding two numbers, if there is a carry from D3 to D4, then auxiliary carry flag is set. Otherwise it would be clear, which is equal to 0. And this is important when we are doing BCD, binary coded decimal arithmetic. We will see in the next slide what is BCD addition. So it is in that context that auxiliary carry flag is taken into consideration. The next one is parity flag. See, in your LCD you would have studied about odd parity and even parity. Okay. Odd parity means the number of ones is odd, and even parity means the number of ones is even. Okay. So the parity flag reflects the number of ones in the accumulator. Remember, always in the accumulator. If accumulator register contains an odd number of ones, then parity flag will be equal to 1. Like I can say set to be set. If A has even number of ones, then parity flag will be equal to 0 or it will be reset. Set means the parity flag value will be equal to 1. Reset means the parity flag value will be 0. So the parity flag is set based on the number of ones in the accumulator register. Very important. If there are odd number of ones, parity flag will be equal to 1. If there are even number of ones in the accumulator, then the parity flag will be equal to 0. So this is the third conditional flag, which is the parity flag. Now, the last of the conditional flag is the overflow flag. Otherwise, we use a symbol OV, overflow. Okay. See, when you are using the 8 bits, no, D0, D1, D2, D3, D4, D5, D6, D7. This D7 is used to store the sign in signed numbers. So what you have to understand is this D7, if it is equal to 0, it means it is a positive number. And if D7 equal to 1, it means that it is a negative number. Because when we want to store the negative numbers, we have to use 1 bit for the sign. Okay. So when signed arithmetic we are doing, if the result is too large, if the result of the operation is too large, causing the higher order bit to overflow into the sign bit, there will be an overflow from D6 to D7. So the sign of the bit will be, the sign of the number will be affected. Because D7 we are storing the sign. D7 equal to 0 means it's a positive number, and D7 equal to 1 means it's a negative number. So if there is an overflow into D7, overflow always means overflow into the sign bit. So if there is an overflow, the sign will be affected. Positive number is a negative number, negative number positive number. Angane overflow overflow flag is set. So in general, carry flag is used to detect errors in unsigned arithmetic. And the overflow flag is used to detect errors in signed arithmetic. So that is the importance of overflow flag. Okay. So clearly understand what are the different conditional flags and when they are set. Carry flag is set when there is a carry from the D7 to D8. Auxiliary carry flag is set when there is a carry from D3 to D4. And overflow flag is set when there is a carry to the sign bit, that is a D7 bit. And that happens only in signed arithmetic. And last one is parity. It depends upon the number of ones in the accumulator register. So very important topic. What are the four different conditional flags? So let us do a problem. Show the status of carry flag, auxiliary carry flag and parity flag after the addition of 38H and 2FH in the following instructions. We are using move and ADD instruction to add the numbers. So we have to add 38 and 2F. Okay. So 3 is 0, 0, 1, 1. 8 is 1, 0, 0, 0. 2 is 0, 0, 1, 0. F is 1, 1, 1, 1. You have to add these two numbers. 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 1 is 0, and you have a carry. So this will be carried to here, and 1 plus 1 plus 0 is 0, carry 1. 1 plus 1 plus 1 is 1, carry 1. 1 plus 0 plus 0 is 1, carry 0. And 0 plus 0 plus 0, 0, carry 0. So you have 8 bits, 9 bits as the answer. And when you are coding it, what you will get? You will get the answer as 0, 1, 1, 1 is 7. And 0, 1, 1, 4 plus 2 is 6. So it is 67 in hexadecimal. Now you are asked to find what are the values of flag, auxiliary carry flag and parity flag. Okay. So carry flag is set when there is a carry from D7 to D8. So there is no carry. So your answer is, here there is no carry. So it is 0. Auxiliary carry flag is set when there is a carry from D3 to D4. So this is D3, this is D4. So there is a carry from D3 to D4. So auxiliary carry flag is 1. And parity flag is when the so we have 38. So when we look into the parity flag, you can see 1, 2, 3, 4, 5. There are 5 ones. So it has odd number of ones. So if there are odd number of ones, P will be equal to 1. So our parity flag will be equal to, parity flag depends upon the number of ones in the accumulator. So there are 5 ones, that is odd number of ones are there. So the parity flag will be equal to 1. Parity flag will be set if there are odd number of ones. So we'll see the answer. 38 plus 2f is equal to 67. Carry flag will be equal to 0. Auxiliary carry flag equal to 1. And parity flag is equal to 1. So this is the, we have to write the explanation also. Now we know about the banks in 8051. There are 4 banks. Bank 0, Bank 1, Bank 2 and Bank 3. So Bank 0 will have address from 00 to 07. Bank 1 will have address from 08 to 0F. Bank 2 will have address from 10 to 17. And Bank 3 will have values from 18 to 1F. Now we want to select these 4 banks. So that is based on the values of RS1 and RS0 in the program status word. That is why we are going to see this topic. Now you can see the address of each bank and the registers. So in bank 0, you can see R0 has an address 0, R1 has an address 1, R2 has an address 2 and so on. So bank 1, the starting address is 8, 08, 09, 0A, B, C, D, E, F and so on. Bank 2 will have address from 10, 11, 12, 13, 14, 15, 16, 17 and bank 3 will have R0, 18, R1, 19, R2, 1A and so on. So these are the addresses of each of the registers in each bank. So one question, state the contents of the RAM location after the following program. So it's a very simple move instruction. So move R0, #99. So R0 means it is location 0. R0 is location 0 of bank 0, no? So R0 location is 0. So in the location 0, the value 99 is moved. So if you are drawing the memory, you can draw it very neatly. I am drawing in. So you have the address 0, 1, 2, 3, 4, 5, 6, 7. So R0 will have the value 99. So location 0 will have 99. R1 will have 85. So location 1 will have the value 85. R2 will have 3F. R7 will have 63. And R5 will have 1, 2. So this is the location, content of the RAM location after the program. So this is all in the bank 0. That is why we moved into the locations between 0 and 7. Now how to select the bank? As we saw, RS1 is PSW.4 and RS0 is PSW.3. So if you want to select bank 0, you should give the values 0 to RS1 and 0 to RS0. If you want to select bank 1, you should give 0 to RS1 and 1 to RS0. Bank 2 means 1, 0. And bank 3 means 1, 1. Okay, so you can set the values by the command stb. We've already seen this command psw.3. That means psw.3 means it is rs0. So rs0 is equal to 1. Whereas what about psw4? We are not changing the value. That is rs1 is equal to 0. So the rs1 will have 0, 1. rs0 will have value 1. So bank 1 will be selected. So you can select the each of the bank according to these different values. Similarly, you have the clear instruction also, CLR PSW.3. That means PSW.3 will get the value RS0. This is equal to 0. So the combination will be 0, 0 and the bank 0 will be selected. So you can select the different banks by changing the value of PSW.4 and PSW.3. So let us do one question. State the contents of the RAM location after the following program. STB PSW.4. So PSW.4 means RS1. What does it mean? RS1 is equal to 1. So what is the combination? RS1 equal to 1 and RS0 is equal to 0. So 1, 0 means the bank 1 will be selected. Bank 2 will be selected. Bank 2 will be selected. So here we have to remember that we have to write the address of bank 2. So what are the values? Bank 2 values we have seen here. Bank 2 value starts from 10. So the address is 10, 11, 12, 13, 14, 15, 16, 17. And what are the contents? R0 will have 99, R1 will have 85, R2 will have 3F, R7 will have 63 and R5 will have 12. So these are the values of the RAM location after this program. So important one is this instruction. You have to see which bank is selected. Accordingly, you have to change the values of the RAM location. So here I have given the solution. So PSW4 means RS1 equal to 0 and RS0 equal to 0. So bank 2 will be selected. Bank 2 will have address from 10 to 17 and accordingly you have changed the values of each locations. I hope it is clear. So this is a very important topic. What is PSW? What are the contents of PSW? And inside the PSW we have the conditional flags and the selection of the bits. Two other bits are not defined. So I hope you understood this. So please go through this and study this. Thank you.